Hi, in this video we're going to talk about algebraic expressions. Many problems in understanding algebra can be traced back to an inability to properly read an expression and understand the operations involved. So we're going to learn how to read an algebraic expression. Most expressions that you encounter in an algebra course can be classified either as a sum or a product. Let's look at some expressions that are sums. Okay, here's a simple sum, x plus y. Now sums are expressions involving an addition, and the different parts that are added, the x and the y in this case, are called the terms. So that particular sum has two terms in it. Okay, here's a more complicated sum. X squared minus 7x plus 1. There is a subtraction involved, but all subtractions can be eliminated in favor of additions. This is the same as x squared plus negative 7x plus 1. And this is a sum of three separate terms. The first term is the x squared, the next one is the negative 7x, and the last one is the 1. These three terms are being added up, so this is a sum. Okay, now let's focus on products. Let's talk about some algebraic products. Okay, here's a very simple one. AB. Now I haven't written a symbol between the letters, but when things are next to each other like this in an algebra course, the operation implied is multiplication. That means the same as A times B. Now the different things that are being multiplied, the A and the B, are called factors. In a product they're called factors, not terms. So this product has two factors. Let's look at a more complicated product. 3xy, which means 3 times x times y. We're multiplying three factors together in this product. And let's look at one more. 5x squared y. Okay, this is a product as well, and you can think of it either as having three factors, the 5, the x squared, and the y, or if you expand out the exponent, x squared is the same as x times x. Then you can see it as having four factors. Okay, either way it's a product. So these are all products. Now what I really want to get at in this video is more complicated expressions that involve both of these operations, additions and products, in the same expression. And I'm going to write down some expressions and ask you to consider whether the expression is a product or a sum. It has to be one or the other. Okay, let's take this as an example. Okay, in this expression there are a few operations. There's this addition in the first set of parentheses, there's an addition in the second set of parentheses, and there's an implied multiplication in between the parentheses. So we have multiplications and additions. So which one is this, a product or a sum? Okay, it turns out to be a product. If you're not sure about that, I'm going to discuss how you decide whether it's a product or a sum. It has to do with the order of operations. Imagine you were evaluating this expression. In fact, let's do so for a particular value of x. If I change the x into a 7, then this expression will evaluate to a number. Now when you compute this expression, follow the order of operations and ask yourself, which operation are you going to do last? That's the big question here. What operation is last in this computation? Well, according to the order of operations, we have to do the sums in the parentheses first because they're enclosed in parentheses. So this would be 8 times 9. And then the very last thing you do is the multiplication. So the multiplication is done last. Whatever is done last is indicating whether it's a product or a sum. Since the multiplication was last, that means this is a product. So x plus 1 times x plus 2 is a product. Another bit of terminology I like to use in my classroom is I talk about the main operation in an expression. And there are three operations in this expression. The main one is the one you do last. This multiplication is the main operation. And that tells you that this is a product. Okay. And how many factors does this product have? It has two factors. There are two factors being multiplied. The first group of parentheses and the second group of parentheses. So x plus 1 and x plus 2 are the factors. Okay, let's turn our attention to another expression and decide if it's a product or a sum. Take a look at x minus 7 times x plus 1. Now there are three operations here. There's the addition in the parentheses, there's the multiplication between the 7 and the parentheses, and there's the subtraction. Let's get the subtraction out of the picture first by changing it into an addition of the opposite of 7 times x plus 1. Okay, so we have both multiplication and additions in this problem. Is this a product or a sum? Well, decide what the main operation is. What would the last operation performed be if you were doing the order of operations? If it helps, put in a number for x, such as 5, and actually perform the order of operations. Well, this would be 5 plus negative 7 times 6, doing what's inside the parentheses first. And we have an addition and a multiplication remaining. Multiplications come before additions. So this is 5 plus negative 42. And then finally, the last thing we do is an addition here. So this is our main operation, that addition. It's the last operation done. And so this is a sum. That main operation is a plus sign. That's a sum. And we have two terms, the x and the rest of this, negative 7 times x plus 1. There are two terms in that sum. Okay, let's look at one more, maybe a couple more. Take a look at a times the quantity x plus y plus b times the quantity x plus y. Decide if this is a sum or a product. Okay, I'm going to run through the order of operations a little more quickly this time. Okay, we're going to be doing the additions in the parentheses first, okay, then the multiplication between the a and the parentheses, and the multiplication between the b and the parentheses. Once those products are complete, the last thing you do is that addition. That's the main operation in this expression. Since it's an addition symbol, this expression is a sum. And the sum has two terms. The a times x plus y is one term, and the b times x plus y is the other term. So that's a sum. Let's look at one last example. Let's take a look at 3 times x minus 2 times x plus 1 plus 4. Now this is rather complicated, and we could actually simplify it, but let's leave it unsimplified and decide if it's a product or a sum. Okay, first thing I'll do is get rid of that subtraction in favor of an addition. So I'm going to add a negative 2 times x plus 1 here. So my operations are multiplications and additions. I have 1, 2, 3 additions, and I have a multiplication between the 3 in the parentheses, and another one between the negative 2 in the parentheses. So I have two multiplications. So decide which is the main operation. What would be done last? Okay, well, we're going to do everything inside of that outer group of parentheses first. If we were evaluating this expression, we would have to compute the x plus -2 times x plus 1. We would have to compute all of that first. Then we would multiply that by 3. And finally, the last thing we would do is add that result to the 4. So this is our main operation. Since it's a plus sign, that means this is a sum. Now, it's a rather large expression, but it only has 2 terms. The first one is what's to the left of the plus sign, and the second one is the 4 on the right of the plus sign. That's a big complicated term on the left, but it is only one term, and that term happens to be a product, by the way, 3 times what's in the parentheses. And one of the factors, the one in the parentheses, happens to be a sum. Okay, so there are sums inside of that term, but it's all one term. Alright, now that you know how to properly read an expression and decide whether it's a sum or a product, let's talk about some applications of this idea. When does this come up in algebra? Well, it's essential to understanding almost everything in algebra. Almost everything is dependent on you being able to tell whether you have a sum or a product, and to count the number of terms and identify the terms, and count the number of factors in a product and identify the factors. These are essential skills. I'm going to give you just 2 simple applications. Let's start with factoring. And I'm assuming you've done some factoring before, so I'm not going to teach you how to factor here. I'm just going to talk about what factoring is. Factoring is actually the process of changing a sum to a product. That's what factoring is. Factoring is taking an expression which happens to be a sum and finding an equivalent expression that's a product. You're changing sums into products. Every type of factoring you've ever done is that idea. Let me take an example. ax plus ay plus bx plus by. Okay, this is pretty clearly a sum. Now that we've went through all those examples, this is a sum of 4 terms. ax, ay, bx, and by are the terms. So it's not factored. We have to begin to factor it. Factoring sometimes takes more than 1 step. Sometimes it only takes 1 step. This one's going to take 2 steps. And each step is going to reduce the number of terms. At first we have 4 terms. Now what I'm going to do is factor it by grouping. I'm going to group the first 2 terms together here. That's going to be one group. And the last 2 terms will be another group. And out of the first 2 terms I will factor an a. That leaves me with x plus y. And out of the second 2 terms I'm going to factor a b, which also leaves me with an x plus y. So read this expression for a minute. Is this expression a sum or a product? It's still a sum because of this main operation right here. That's our main operation. That's the addition. That's the operation that would be done last. So that means we haven't factored this yet. It's not done. But we've reduced the number of terms. We now only have 2 terms, the a times x plus y and the b times x plus y. To finish this, we take those 2 terms and we factor out the x plus y that they have in common. And that x plus y multiplies an a to give us the first term, and we add, and it also multiplies a b to give us the second term. Now look at this expression and decide what the main operation is. It's this multiplication in between the parentheses. That's the operation that would be done last. So we've succeeded in making this a product. So the factoring is complete. By the way, a product can be viewed as an expression that has only 1 term. So factoring is the process of reducing the number of terms down to 1. That's what factoring is. Okay, one last application to end the video. I'm going to talk about reducing fractions or rational expressions containing some variables. Take a look at this example. X times x minus 2 minus 15 over x minus 2 times x plus 3. Okay, in an algebra class you're often asked to reduce fractions like this. Reducing amounts to always canceling common factors. One factor from the numerator and the same factor from the denominator. You can only reduce if both the numerator and the denominator are products. You cannot reduce until they are products. So look at the numerator for a minute. It has subtractions in it which are equivalent to additions, but ask yourself, what's the main operation? What would be done last? Well, we would do the x minus 2 in the parentheses, and we'd multiply that by the x outside, and this subtraction, which is equivalent to an addition of negative 15, would be the main operation. So that numerator is actually a sum right now. It's not a product. The denominator is a product. It's a product of two factors, x minus 2 and x plus 3. But the numerator has to be a product as well if we want to factor this. So don't make the common mistake that a lot of students make here in canceling out these x minus 2's. Those do not cancel. You cannot cancel common elements of a fraction unless they are factors. That means unless the numerator and denominator are both products. So here's what you would do with this expression. You would try to factor the numerator. You would want to get it into a product. And to do that, you first have to distribute this x to get x squared minus 2x and then minus 15 over this denominator. Okay. Now you can factor that trinomial in the numerator, and it factors as x minus 5 times x plus 3. Now that it's been factored, we do have a product in the numerator and a product in the denominator, which means we're ready to cancel any common factors, and we do see a common factor of x plus 3. Okay, perhaps in another video I will elaborate on canceling and exactly what that is and why we're allowed to cancel those. But for now I wanted to illustrate that you needed products before you canceled. Okay, hopefully this video will help you in your algebraic studies. Thanks for watching.